got?
Okay, well, it says to use my Inspire calculator for some questions.
Okay.
So, I mean,
I have an
I don't
Inspire, so I might be able to help you with that. I'm not sure I'm an expert on it. It depends on what you need to do on it.
I think it's more of that regression stuff. I'll just read you the problem.
Okay.
So it says Tony is trying to figure out how much prosciutto he should sell, or he should try to sell during any given week in order to maximize his profit. In order to sell more prosciutto, Tony knows that he must lower prices. As such, he has found that the revenue for a given week fits the equation R equals negative 0.54 p squared.
0.54 squared?
Yep, p squared.
A p squared, okay.
Plus 100p minus 105.
Minus 405?
No, 105.
And p is the price that he charges?
P is the number of pounds and R is the revenue.
Okay. P being the number of pounds that he sells?
Yep.
And is this correct? Minus 0.54 p squared?
Yep.
Okay.
And then it says, using your Inspire, what is Tony's maximum revenue?
All right. We don't need to use the Inspire for the moment. Let's look at what we're looking at.
Okay.
That's a quadratic, right?
Right.
What kind of graph is that?
Oh, just what kind?
Parabola.
Oh.
All,
Oh, okay.
all quadratics are parabolas.
Okay.
Is this a parabola that opens up or opens down?
I think down.
Because of that negative sign in front of the p squared term.
Right.
Okay. So this is the p-axis. This is the r-axis. I know that when p is 0, we're down here. So most likely we've got something that looks kind of like this. Okay?
Okay.
And that point right there, the vertex, will be where revenue is maximum. So that's what we need to solve for. And in fact, the only thing we really need to solve for is the solutions to this quadratic. Now,
Oh.
they said use your Inspire, which means they probably want you to graph this on your Inspire, and then use the option that tells you how to get the maximum or the minimum. But we know that the horizontal coordinate is minus b over 2a. That will give us our answer immediately. Faster probably than you can graph it and get it.
Okay.
It's minus 100 over minus 1.08. So that becomes plus, well, b is 100. So minus b is minus 100. And a is minus 0.54.
Oh, I see. Okay.
Okay. So whatever that number is, you can use your Inspire to figure out what 100 divided by 1.08 is.
But what is negative b over 2a solving for?
That solves for the x-coordinate of the vertex.
Oh, okay.
For any quadratic, that's actually the quickest way to find the vertex. If you have a quadratic in standard form, which this is, it's ax squared plus bx plus c, that's standard form. If you have it in that form, the fastest way to find your vertex is minus b over 2a. Now, that doesn't give you both coordinates of the vertex, but it gives you the x-coordinate, or in this case, the p-coordinate. When I say x, I mean the horizontal point. where the vertex occurs.
Okay.
Okay? And that's really the easiest way to do it. You want practice with your Inspire?
Well, my Inspire, I use the Inspire at school.
So you don't have it in front of you now?
No.
Okay. Not going to be much good for me to do it on mine. If you need practice on how to do this on your Inspire by graphing it and finding the maximum, let me know and we can go over that anytime.
Okay.
But you probably need the Inspire in front of you for me to be able to direct you as to how to do it.
Yeah.
There's quite a learning curve on that Inspire. Have you had it for a long time or just recently?
Just recently. It's interesting.
A lot different than the TI-84 if that's what you came from.
Yeah.
Most people do. And it's a totally new operating system, basically. It's nowhere near as close to the TI-84, so it's really hard to get used to the Inspire.
Yeah.
And I can help you with some things. I know quite a bit about it, but I can only help you if you have one in front of you so that we can both, talk about the same thing. But any quadratic is a parabola, and if it were a parabola that opened up like that, then they would be asking what's a minimum point. And the minimum point occurs at that vertex. But they're always asking for that. Now, if they said to you, how many pounds should he make? I'm a little confused here. When you read the problem, you said that his revenue changed by how much he charged. And he wants to figure out how much he charges to maximize his revenue. Well, nowhere in here is there anything about charging if P is equal to the number of pounds that he sells. Did I miss something there?
Do you want me to read it again?
Yeah, go ahead and read it one more time.
Okay. Tony is trying to figure out how much prosciutto he should try to sell during any given week in order to maximize his profit.
How much? Okay, I misheard it the first time. I heard how much should he charge, and the question really is how much should he make? In other words, how many pounds should he make?
Yeah.
And that's what P is. Okay. But yeah, it's a pretty straightforward problem if you're just having to solve for the x coordinate of the vertex. Now, the second part to that problem is probably going to be how much revenue is that?
Yeah. Yeah.
Okay. That is the y coordinate. That's that value right there. And how do you get that? You take the P answer that gives you, you plug it back into the original formula, and whatever R comes out to be with that P, that's how much revenue. And you can be confident that that's the maximum revenue. Notice there's no place else on that curve that's higher than that point in terms of revenue.
Okay.
And there is a formula for the y coordinate of the vertex, but nobody memorizes it because it's basically just easier to take the x coordinate, or in this case the p coordinate, and plug it into the equation and figure out what r is when p is equal to that.
Right.
All right. What else you got?
There are all kind of questions along this problem.
Okay. Let's do another one.
But it says, how much is he charging per pound in order to maximize his revenue? It says price per unit equals R divided by...
Whoa. This is a different problem, right? Or is it the same?
Yeah.
Okay, different problem altogether. How much should he charge? Okay, is there a different equation for this one?
Oh, it's the same one.
Same equation. Now I am confused. We had r equals minus 0.54p squared. What was the rest of it?
Plus 100p minus 105.
105?
Yes.
And p equals what?
P equals, that was,
In the first problem, p was the number of pounds that would, that's totally different than what he should charge.
yeah.
So what other,
Price per unit is the revenue over pounds.
okay, all right. Revenue, so the price is revenue divided by P. Okay, well, in the last problem, we figured out what P and what R, right?
Yes.
Okay, take the answer you get for the R divided by the answer we got for the P, and that's your answer.
Okay, yeah, that seems easy enough.
Yeah. But again, you have to use minus b over 2a to get the p-value that's the
Yeah,
option.
I think it ends up being like 92. I have to calculate it again.
Yes, it is about 92. 100 divided by 1.08. But that's p. What r is equal to, I don't know. You're going to have to plug in that p up here and come up with a value.
Yeah.
Once you do, then that's your r. And if price is r divided by p, then that's the optimum price.
Okay.
I guess. I don't like that particular model because if you had a restaurant, you'd always want to optimize. I guess you'd always want to optimize revenue. I'm a little confused as to why price is here and why it's equal to revenue over P. I guess if you take your total revenue and divide it by the total number of pounds of food you're selling, you get the price per pound that you should sell it for.
Yeah. Yeah, she didn't talk about this much, really. She kind of just gave us.
Yeah, that's a bit of a strange problem, but let's not get too hung up on it. Do you have others
Yeah.
besides this one? Or are there more parts to this one?
Yeah, there's the only thing I'm confused on is like the other parts to this one.
Okay, let's talk about that. What else?
Okay, well, another question is, profit is the amount of money left after paying expenses.
Okay.
Profit is revenue minus cost. What is Fat Tony's maximum? Yeah, they keep referring to him as Fat Tony. I don't know that. But they said, what is Fat Tony's maximum profit? How many pounds of prosciutto does he sell at this point?
We know anything about cost?
I don't even think so. Yeah, I don't think so. It says, given the cost and revenue equation, what are Fat Tony's?
What's the cost equation?
It says, Tony has a weekly fixed cost of $1,000 and has to pay $15 a pound for prosciutto.
Okay.
We have to write.
So the cost is what? What's the cost function? How much per pound?
15 per pound.
15 $15 per pound of risotto?
Yeah, and then
Plus
weekly fixed costs,
how much?
$1,000.
I didn't catch that.
It says, I'll just read you the problem. Tony has weekly fixed costs of $1,000 and has to pay $15 a pound for his risotto. Write an equation that represents the total cost of risotto.
So that's it right there. There's the cost equation, right?
Okay.
In other words,
Yeah.
if you're going to sell 100 pounds of risotto, then it costs you $15 per pound, so it's $1,500 plus 1,000. So this is all your costs. The only cost you have is for the pounds of risotto and that fixed cost that doesn't change.
Yeah.
Okay. Well, now we have a revenue equation, which is at the top, and we have a cost equation, which is right there. So, profit is equal to revenue minus cost, which in this case is this equation minus this equation. What do you get when you subtract cost from revenue? What equation do you get?
When you subtract,
Yeah, subtract the right hand, 15p plus 1,000.
Okay.
The right side of this equation. In other words, if I want the equation revenue minus cost, here, let me, one man. Let me write it. It's minus 0.54p squared plus 100p minus 105. That's our revenue. Minus our cost, which is 15p plus 1,000. Right?
Right.
Now combine those two. What do you get?
Combine them?
Uh-huh. In other words, you can subtract. There's nothing. I got 100p over here, and I'm going to subtract 15p.
Well, first I have to distribute the negative, right?
Right. And we only have one p squared term, and that's that one. So, yeah, first you got to remove the parentheses, which means distributing that to the 15p and the 1,000. So after I do that, now combine this 100p and that minus 15p, gives you 85p. And now combine the minus 105 with the minus 1,000.
Wait, oh, right, okay.
Which is minus 1105. So that's a different function. That's your profit. Okay? Now, if I want the maximum, in other words, the P that maximizes my profit, then I've got to find the vertex of that. So what's minus B over 2A?
That's going to be, like, are you asking me what that...
Yeah. In other words, the next step for finding the P that's going to maximize profit is to find the vertex of, this is another parabola.
Oh, yeah, okay, so that'll find the x value.
You got to find the, not the x value, but the P value. Because the horizontal axis here is P. The vertical axis is profit. This is a little different. In other words, the last time we graphed it, we had P as the horizontal axis, revenue as the vertical axis.
Okay, well, how did you determine what axis, or what, like, why...
I'm looking at this equation over here on the right. The dependent variable is clearly P. The independent variable, I got that backwards. The independent variable is P. The dependent variable is profit. So I know the horizontal axis is whatever the independent variable is. That's the thing I can change. right?
Right.
I can increase or reduce the number of pounds of risotto that I get, or whatever this thing was. But the key thing here is that my profit graph is not the same as my revenue graph.
Okay.
Okay? So it's not going to have the same value of P to maximize profit. That value of P we came up with before maximized revenue, but it didn't look at cost. So you don't always want to max. If you own that restaurant, you wouldn't really be interested in maximizing revenue. What you're interested in maximizing is profit. You don't care if you make $1 million in revenue if you lose money. You don't want to make $1 million in revenue. But if you made $100,000 in revenue and that gave you a profit of $50,000 and that's the most you could make, well then that's how much food you want to make.
Hmm.
So
Okay.
in this case, minus b over 2a is minus 85 over that same minus 1.08. So what's 85 divided by 1.08?
85. 78.
78.3?
70.
70.3? It doesn't sound right.
78
70.
point.
I was going to say 70 didn't sound right. 78.3?
No, 78.70.
Oh, gosh. Sometimes the audio isn't that great. Sometimes it isn't. I don't know. But anyway, so by purchasing 78.7 pounds of this stuff, that gives him the maximum profit, which is that point right there. If he produces less, he gets less profit. If he produces more, he gets less profit. There's only one spot on that curve that gives you a maximum profit, and that's this point right there. And that's what you're solving for when you solve for minus b over 2a, is that point.
All right.
Okay?
Okay, that makes sense.
And as far as which axis is which, if you have something that's a one thing on the left, like revenue or cost, and it's equal to a quadratic in P, well then clearly that's the horizontal, that's the vertical.
Okay. Yeah.
Whatever the variable is in the quadratic is the horizontal axis, always. And
Okay.
the other axis is whatever's on the other side of the equation. In this case, it's profit. In the first problem, it was revenue.
Okay. It's weird how they gave us like two equations.
I'm sorry, what?
I don't understand why she would give us like two different equations.
Well, I think she's trying to impress upon you the fact that the revenue quadratic is not the same as the profit quadratic. And therefore, when you maximize revenue, you're not really maximizing profit. You're maximizing revenue. You get the most amount of revenue if P is equal to 92 or whatever you came up with there on that previous problem. That maximizes revenue, but it doesn't maximize profit because profit is revenue minus cost. And we have a different cost function over here. So if you subtract the cost function from the revenue function, you end up with this function at the bottom of the page here. That's the profit function. Now, if we want to maximize profit, it's a totally different value for P. It's 78.7. So he's going to buy this much food. He's not going to buy the 92. He doesn't want to maximize revenue. He wants to maximize profit. Any businessman always wants to maximize profit, not revenue. He doesn't want to minimize cost either. He wants to maximize profit.
Okay.
Okay? On a word problem like that, might be a little bit better if you sent me a picture of it. Just,
yeah.
It's probably a little easier for me to understand if I can read the problem as it is on the piece of paper. Just for future reference, let's do that. If you've got a complicated word problem, that's almost like a graph that needs to be interpreted. All right. Anna, I will talk to you next Monday.
Okay.
Okay? All right. Have a good weekend. Bye-bye.
Bye.